This chapter will be a bit different from the others. Step by step, we're going to work towards a cool script, using everything we've learned during this course. Imagine this situation. You're walking up the Empire State Building and you're playing a game with a friend. For 100 times, you throw a dice. If it's 1 or 2, you go 1 step down. If it's 3, 4 or 5, you go 1 step up. If you throw a 6, you'll throw the dice again and will walk the resulting number of ice up. Of course, you cannot go lower than step number 0. And also, you admit that you're a bit clumsy and have a chance of 0.1% of falling down the stairs when you make a move. Falling down means that you have to start again from step number 0. With all of this in mind, you bet with your friend that you will reach 60 steps high. What is the chance that you will win this bet? It's a complex assignment. One way to solve this would be to calculate the chance analytically. Another approach is to simulate this process thousands of times and see in what fraction of the simulations you will reach 60 steps. This is a form of hacker statistics. As you can probably guess, we're going to opt for the second approach. The first thing we'll need are random generators, so we can simulate the dice. You need to import NumPy, and inside NumPy there's a random package. Inside that package we find the rand function. Let's try it out. We get a number between 0 and 1. How is this random number created? Well, computers typically create so-called pseudo-random numbers. Those are random numbers that are generated using some kind of mathematical formula, starting from a random seed. This seed was chosen by Python when we called the rand function, but you can also set it manually. Suppose we set it to 123, just the number I chose, like this, and then call the rand function twice. We get 2 random numbers. Now, if I set the seed back to 123 and call rand twice more, we get the exact same random numbers. This is funky. You're generating random numbers, but for the same seed, you're generating the same random numbers. That's why it's called pseudo-random. It's random, but consistent between runs. This is very useful, because this ensures reproducibility. If you run different versions of the same algorithm, you know that they are using the same random numbers, so you can make a fair comparison between these versions. Let's use this randomness in a new example now. Suppose we want to simulate a coin toss. First set the seed, again this could be anything, and then use the randint function. To have it randomly generate either 0 or 1, we pass 2 arguments. The first argument should be 0, the second one 2, because 2 is not going to be included. If we print out coin and then run the script, we get a random integer, 0. You can now use this coin to play a game. We extend the code with an if-else statement. If coin equals 0, we print out heads. If it equals 1, we print out tails. If you now run the script, coin will again equal 0, because the seed is the same. This also means that the if condition is true, so the string heads is printed out. This was a first example on how you can use random numbers to simulate real-life situations that involve chance or probability. Now head over to the exercises and start to code your Empire State Building simulation.